something else on Monday, so you're gonna have your review on Tuesday, and then your quiz is still Wednesday. Okay. So today we're gonna go over slopes of lines, and those are the slopes that are parallel and perpendicular. Okay, so just starting with slopes of lines and then moving into parallel and perpendicular slopes. So this first example I have here, number 1, I want you to do in your groups. Okay, you know all of what a slope is from algebra. Use that information to answer A, B, and C in number 1. Okay, with the person sitting next to you.
So you just didn't do the homework? So do you know what's going on?
Wait, you just don't do it?
No, I haven't doing it on the test yesterday. Yeah, so I didn't do this because I didn't want to do it that day.
Okay, because I was like, Izzy, what is your grade in this class?
I actually have a B plus.
Okay. The first problem is just on slope. You took algebra, so you figure that one out. It's not what we did yesterday.
Guys, Sophie scored really high.
You know what? Higher thing. Killer?
Ouch.
Maybe there was no ramp.
No. We gotta do this. Stop distracting me.
Hey, you should be answering A, B, and C to the best of your ability.
Yeah, the height would be the rise, and then the run would be the steps. Right? Yeah?
The math ACT is very interesting. Alright.
But I don't have my phone, so I don't have a calculator. And I can't get the slope.
What do we need?
Because you know what I did? I left my phone in my So.
What do we get?
Okay, it would be 2 over 1, and then
Y equals mx plus 1.
Equation of a line. What's M? Find M.
Bro. X and Y, right? Oh,
Which one's your right?
steps is rod, height is so it's 1 I was gonna disagree. Yeah. Rise over run, so it wasn't the.
I forgot how to find slope. How do you find slope?
Height is the rise.
Jessica.
Rise over run.
Jessica,
Yes.
how do you find slope?
What? Rise over run. That's all I know. Oh.
Can you get your phone? Look up how to find slope.
I was really confused.
Was 1 half. So they rise half foot each step they take, right? So after 10 steps, how much do they rise?
I feel like it was like I1 minus
5 feet. There we go.
something.
No, I'm trying to figure out how to find slope. I can't remember.
Yeah, I literally was like, why
Oh, y2 minus y1. That's what it is. Okay. So y2 minus y1 over x2 minus x1.
So now we have to find what x1
Okay,
and 2 and
so we could do. Okay, so the height would be x and the steps is y. So it would be so 3 minus 2 over 3 minus 1. So it'd be 1 over 2.
Yes.
0.5. So that's his slope. This one is 0.5, and then James would be 7 minus 1 is 6, 8 minus 5 is 3, which is again, this is 2 over. Ooh, big guy.
Skip it like 3 steps.
Yeah. So after 10 steps,
I can draw an abstract.
they would, after 10, Pillar would be at 5, and Jake
So
over
it's
here
3
is at,
over.
wait,
It's 6 over 3. How is it 6 over 3? If you subtract it, it's equal to 2
wait, and
over
then
1.
you just, what do you do after slope?
The slope tells you how much they rise
Yeah,
after one step.
okay, so after 10 steps, he is at 5 and Jake is at 20.
This is called
They're both rising half a step.
Oh.
You put
I don't know.
Oh, okay, never mind. So they're both at 5.
So they
Yeah.
would rise 5 feet
Expect them to be the same size?
I don't know.
after 10.
They're not the same.
Okay, I have a question. So wouldn't it be 8 minus 5 and 7 minus 1 to get
Boom. That looks like Tom.
3 over 6?
Will Pillar and Jake are the same height?
Yes, so then they
They
would be
have the same height.
No.
so they rise the same amount. No, it's no because they rise the same amount but they start at different heights.
Are you sure he's into the physics?
How high they're starting on.
I love this.
So she's starting at 1.5 feet up. She's starting at 4.5.
I bet you expect me to-
That's a lot.
Rising
Not
at
more.
the same rate.
Wait, peeling the extra marker off? I was trying to do that.
Bailey did it. How do you
Wait, did Bailey do it?
Color drawing, you can tell.
There's no way.
Wait, what is it?
You draw a line.
When they're starting,
Wait, do you have to like block?
I don't know.
shoot that feet at 1.5.
That's what my handwriting is here.
Oh, geometry.
Pull.
Why?
What are you doing?
This, watch this.
He's trying to peel the expo marker.
Watch this.
Yeah, you do.
You can see that.
I want you to go.
They peel it. Like
You would like make a blanket, okay, so marker.
Watch, watch. Watch him do this.
That actually looks kind of cool.
Watch.
Watch this.
Oh, and he starts first.
It's not right here. Look. Watch this. How do you do it?
I don't know.
That.
I'm done.
You did all three.
Definitely. I did the first
Why
one.
would you? No, what would you? Why can't I read it?
You guys should be doing all three of these problems. And try to answer them.
Wait, like all three examples? There's more.
These just A, B, C.
Oh, okay.
You ever create a plan for the first thing?
So this is slopes of lines. So solve, use slope to solve problems about parallel. So it's gonna be something with that, because that's what we're learning. You just saw a lot of things.
That was good.
Thank you.
What do you know about their rate? Their rate of change?
The same.
It's the same. So what do you know about the same slopes? What would those two lines be?
Parallel. They have the same rate of change, therefore their lines are parallel because they increase at this height at the same time. I'm like, yes, that's the answer. I am in public. I'm so captivated right now. Right?
Oh my god, I'm so dyslexic. Four, and I wrote 5. Is there a symbol for slope?
M?
Why is it?
Slopes? I don't know, because it's y equals mx plus b and slopes intersect form. I don't know why they call it that.
You should just call it
call it S. I think S's look too much like 5s. So it's kind of difficult there. Okay, so I gave you some time here to try and remember what slope means and what rate of change means. Okay, so in example 1, you have Pilar and Jake begin climbing to the top of a 100-foot monument at the same time along 2 different sets of steps at the same rate. Okay, so you know their rate is going to be the same. That means the slope of both of these lines should be the same. The tables show their distances above the ground level after a number of steps. So in letter A, we have how many feet does each student climb after 10 steps. So first we want to figure out what their rate of change is. So recall that finding the slope is your change in y over your change in x. Okay, so you have your change in y over the change in x. Now, in our tables here, your change in y is your height. Okay, so that's how high they would be climbing, and your change in x is your steps. So I can just take my 2 heights here and subtract them. So I have 3 minus 2 over 3 minus 1. That is 1/2. Now you can also check that slope for Jake, but it should be the same, okay? Because it said their rate of change is the same. Okay, that rate which they climb at is the same. So then after 10 steps, how many feet does each student climb? Well, I would just need to take 10 times that rate. Okay, so 10 times 1/2 is 5 feet. Okay, and that is because they're going at that same rate. They're climbing 1/2 foot for each step. Okay, letter B. Will they be at the same height after the same number of steps? Are they going to be at the same height? No. Why?
Because they rise at the same amount that they started doing.
Yes. They rise at the same rate, but they're starting at different points. Okay, so Jake is starting higher up. So after those 10 steps, he will still be higher than Pilar. Okay, letter C. What would you expect the graphs of each to look like given your answers to part A and part B? So if they have that same rate of change, what would you expect that graph to look like? They have that same slope. What would you expect the graph to look like?
Parallel lines.
They would look like parallel lines. Okay, so they would be parallel. Meaning they would never intersect. Since the slopes are the same. Okay, slope kind of coming back to you, that rate of change. Yes? So we are going to use slope today to look at slopes of parallel lines and perpendicular lines. Okay, so we're going to start off with parallel lines. So in our picture below here, if we have P and Q are both not vertical, so they're not up and down, right? You can see they're kind of slanted here. Okay, then P is parallel to Q if and only if the slope of line P is equal to the slope of line Q. Okay? So those slopes have to be equal to be parallel. Now, if P and Q are vertical, okay, if they're both perfectly vertical like this, then yes, they are parallel. But they both have to be vertical. Same thing with horizontal. They both have to be horizontal. Okay, so two non-vertical lines are parallel if and only if their slopes are equal. And any two vertical lines are parallel to each other. So we are going to do an example to see if two lines are parallel to each other. So in example 2, we're determining if lines K and N are parallel from this graph over here. Now finding slope given a graph is a little bit easier. You can just count your rise over your run on your graph. Okay, so finding the slope of line K is right here. So I need to find 2 points on line K. So I have one right here and another right here. Okay, so just finding 2 points on line K. Now to find that slope, we can just go from one of the points and we want to count the rise, so how much it goes up. So we're going up 1, 2, 3, 4, 5. Okay. So we're up 5. And then to the left, 1, 2, 3, 4. Okay, so if we go left, that is negative. So the slope of line K is negative 5/4. So next we want to look at the slope of line N. Okay, so line N is right here. Again, we want to find those 2 points. So I have a point here, and I have a point here. And then from those points, we want to count the rise first, so the up and down. So I go up 1, 2, 3, 4. And then I'm going to go left 1, 2, 3. And again, when you go left, that is negative. Okay, so the next step when determining if these two lines are parallel is to compare those slopes. Now with parallel slopes, the slopes have to be the same. Are these slopes the same? No. So the slopes are not the same. So the lines are not parallel. So for this one, you would say no, these lines are not parallel. It's okay. I don't know. We'll see where we get to.
How about we work through this?
If we don't get through all of it, you don't have homework, if that makes you feel better.
Take your time.
All right, so on the next page, I want you to try it, okay? On the next page, you're doing the same process. So you're finding if lines M and Q are parallel. So find the slope of line M and the slope of line Q, and then compare those. Multiply them together, and if you get negative 1,
Of course they're not parallel, they're nearly perpendicular.
So if you multiply these two fractions together, do you get negative 1?
1 negative. No, it's not. Negative 1. No, it's going backwards. Oh, no. No, the last one. No, it's down and to the left, so then it would be 2 negatives. Wait. Yeah.
Yes, it's positive, correct. Because if you have the two negatives, right, the negatives cancel, you get a positive one.
Here we go.
Okay, did we find these?
Yeah.
Oh, did you do nothing for 10?
Lines of M equals
Does it have handwriting? That's all like my note. Like it just this is my thing. And then my other handwriting's
All right, what is the slope of line M? What is that slope? 1/3. What is the slope of line Q? 2/5. Are these lines parallel? Why? Okay, they are not parallel. Okay, the slopes are not equal. Okay, when your slopes are equal, that means they are parallel. Okay, these slopes are not equal. Okay, questions on parallel slopes. Okay, next we're going to look at perpendicular slopes. Okay, so if P and Q are both not vertical, then P is perpendicular to Q. That's what that symbol means, perpendicular to Q. If and only if the product of their slopes is -1. Okay, product of the slopes means you can multiply them together and you will get -1 as your answer. Okay, if one of P and Q is vertical and the other is horizontal, then P and Q are perpendicular. So if you have a line that is vertical, the line that is perpendicular to that is a horizontal line. Okay, and vice versa. So another way to think about this is your slopes of perpendicular lines are opposite reciprocals. Okay, so slopes of perpendicular lines are opposite reciprocals. Those opposite reciprocals do multiply together to be -1. Okay, they have to be opposite so that you're multiplying a positive and a negative. Okay, that's what that opposite is, opposite sign. Reciprocal meaning you flip the fraction. Okay, you flip that fraction. So example 3, we're deciding if lines J and K are perpendicular to each other. So for step 1 and 2, we're still finding the slopes of those lines. Okay, and we are given a graph. So step 1, we want to find the slope of line J. So on line J, we want to find 2 points of intersection here. Okay, so I have my 2 points. I need the rise over the run. So I go up 1, 2, 3. And then left 2. Okay, and again, if I go left, that is negative. Step 2 is to find the slope of line K. So find 2 points on line K. Then we'll take our rise over our run, so up 1, 2, and right 1, 2, 3. Okay, so with this, to check to see if these are perpendicular, you can think of it as opposite reciprocals. So do they have opposite signs? So one is negative and one is positive. And does your fraction flip? Yes. Okay, so these are opposite reciprocals. Another way to check and compare your slopes is to multiply those 2 fractions together. Okay, if I multiply those 2 fractions together, I do get -6 over 6, which is -1. Okay, so if you multiply those slopes together, they should equal -1. So I can say, yes, these are perpendicular lines. Okay, questions? All right, next one is try it. So you have letter A and B. You have to see if lines H and L are perpendicular and if lines K and M are perpendicular. Keep in mind you already found what the slope of K is. So you have two problems there. See if those two lines are perpendicular.
Mental math.
Were you supposed to do, like, what's the equation to plug those numbers into? Finally.
Y equals mx plus b.
So then you just plug the y there and then.
So you plug in 1 for y and 3 for x, and then
Okay,
plus
and then
b,
plus
and then
b.
solve for b. To get
Got
the
it.
y intercept.
Oh yeah, I did that.
Oh, I forgot we have that on Monday.
I think it's 1/4. I got 2. That's what I got. No. I literally did the wrong time.
I was like, you don't have any points on M.
Sorry.
However, no, it's not. Oh, no, it's not. Right. Okay. All right. So caffeinated. It's great. No, I don't think we'll be done in
Like, I have like 10 pieces.
Oh no, darn.
I have 10 pieces before when I should have been laying on the stage bed, but I was like,
It's okay, Creole's drop a book. It's a briefcase.
wait, have you ever seen the second half?
No, because I always leave before the second half so I can spoil it.
She didn't want to spoil it. She said that yesterday.
Why do you? Yeah, you just have short-term memory loss.
All right, so looking at these two problems. Okay, what is the slope of H? What's the slope of H?
That'd be negative 2/3.
Yep. Okay, what's the slope of L? 5/2, yep. Okay, if I multiply those two slopes together, do I get -1? No, you do not. Okay, so if I were to multiply -2/3 times 5/2, I'd end up with -10/6, which is not 1. Okay, so this is no. Okay, no, they are not perpendicular. Okay, letter B, slope of line K is 2/3. Slope of line M okay, slope of line M is -4. Okay, if I multiply these two together, do I get -1? No. So no, they are not perpendicular. Questions? All right, so next part we're going to do is actually create a line that is parallel or perpendicular. Okay, so we're going to come up with an equation of a line.
This is so fun.
It's great. So we want to write an equation of a line that is parallel and an equation of a line that is perpendicular. So letter A, quiet down now so we can keep going. So what is an equation of the line through P that is parallel to L? That's supposed to be 2, not up. Parallel to L. Okay, so first I want to identify the slope of the parallel line. So I need to find the slope of line L. Okay, I'm given the slope of line L in this equation here. It is 1/2. Okay, so what would the slope of a line parallel have to be? 1/2. Okay, since it's parallel, they should have the same slope. Okay, next I need to solve for the y-intercept of that parallel line. To do that, I need to use my point P. Okay, point P is at 4, 1. Okay, that is your x and y value. So to solve for B, I need to plug in x and y, and I need to plug in m. Okay, so y is 1, m is 1/2, and x is 4. And I need to solve for B. So you're just plugging that point in to your slope-intercept form. Okay, so multiplying 1/2 times 4, I get 2. Subtract 2. B is going to be -1. So then, step 3, writing an equation of this line. We need to keep it in this form. So we would have y equals, our slope is 1/2, times x, and then plus b, b is -1. So we have -1. Okay, so that one's parallel. Next, I need perpendicular. Okay, so what is an equation of a line through P that is perpendicular to L? Okay, well, again, my slope for L is 1/2. Okay, I need to take the opposite reciprocal of that slope. So to find the perpendicular slope, I need the opposite sign. So since this is positive, it needs to be negative. And then I need to take the reciprocal, so I need to flip my fraction. So 2/1, or just -2 is fine as well. Okay, then step 2, same process. I need point P. Point P is at 4, 1. That is your x and y value. So I can plug in x and y and my slope into that slope-intercept form. So I have 1 equals, our new slope is -2, times our x value is 4, then plus b. And then we can just solve for b. So I have 1 equals -8 plus b. Add 8 to both sides to get 9 is equal to b. Okay, so now that I've found B, I can write out that equation of that line to be y equals our new slope for perpendicular is -2 times x, and then plus the B value we found is 9. Okay, questions on how I found the parallel equation of the line or the perpendicular line? Okay, then I do want you to try it for letters A and B. You have to find a line parallel to this through that point and perpendicular. And same thing for B. So you should have 2 equations of a line for each of these. One parallel, one perpendicular, one parallel, one perpendicular. For the last one?
Yeah.
We were stupid, that's what. We shouldn't have a 2. No, because we subbed both of them. I'm really confused.
Right. It's positive 1.
Oh, wait,
And then you subtract 1 from that to 0.
wait, but there is a negative here.
But your point is a negative.
Oh,
So it is positive. So then this should just be a positive 1.
so then, so it's just y.
1/3.
Oh,
Yeah.
look how
And then,
Okay, so the slope. So to solve for the y, but we don't have to solve for the y, we just have to do the
plug it in here, and then it's like, and then 12.1, which would be 6 Oh, yeah.
Do you plug in one number at a time? Like, because if you do both, then it just.
But you can't.
So then you do,
You do plug in both numbers and your slope.
and then you just substitute 2 for b.
And so that's you want to solve for the new y-intercept.
Wait, can I have a question?
Oh, you have to. Oh, no.
And see, now you don't have any homework.
Yeah, look at that.
Would there be negative?
What math is
It doesn't take me that long.
That's good.
Right, the equation is then it would be
Just small one. Oh well. I got the right answer.
Got 4 different equations written down?
Yes, ma'am.
Oh.
Oh, no, homework together.
This is like
That's wrong. No, I really don't. The thing is, like, I know, so, I can do it
Hey, don't mess with my light.
Wait, can you tell me if this is correct?
For parallel, yes. For parallel, you just do negative.
That's what, okay, I knew this.
And then you need to find the perpendicular. Okay. I want you to just finish up the last 2 try-it problems on the note sheet here. So find the parallel and perpendicular equations of those lines for those last 2. And then we'll go over it on Monday, and then we'll do something else with this as well.
So is this meant for perpendicular, the guy who does it in the beginning of that one, opposite? You like
And then you have to
I thought I'd be
Yeah.
I thought I'd be the